This is our last set of examples. I'm going to try and squeeze synthesis and combustion into this example. Our first one is dinitrogen pentoxide plus water. I'm going to go ahead and write the symbols down for this, and then we'll talk about how to identify that it is a synthesis reaction. So dinitrogen pentoxide would be N2O5. And you'll notice that this looks kind of like a double replacement because you've got a compound and a compound. However, if you were to change the cations, in this case they really wouldn't, they're non-metal so they really wouldn't form cations, but if you thought about it that way, the N would go where the H was and the H would go where the N was, but you'd still have HO and NO just like you started with. So that's why you know this is not a double replacement, but rather a synthesis. So if it's a synthesis reaction between a non-metal oxide and water, you look over here, non-metal oxide and water makes an acid. So we're going to put an H. Then we have to put the two nonmetals in order of increasing electronegativity. But we still have a problem because we don't know what the subscript on the oxygen should be. We do know that it's either going to be nitrate or nitrite. So that tells us that there's only going to be one hydrogen in our formula because nitrate and nitrite both have a -1 charge. So to figure out whether it's nitrate or nitrite, we're going to go back over here and look and see what the oxidation state of the nitrogen is. So oxygen is -2. There are 5 of them, which makes -10. So that has to be +10 to match it. There are 2 atoms of nitrogen, so it must be in a +5 state. So I'm going to put a little +5 over here. We also know that nitrates are always -1 for that polyatomic ion. So how many oxygen atoms would we need to make a -1 charge? Well, you know that oxygen is -2. So we're going to put a little 3 outside of the oxygen because 3 times -2 is -6. -6 plus 5 equals -1. So now we have our combos and formulas correct. There are 2 H's, so you have to put a 2 here. That gives you 2 N's, which is nice there because there are 2 N's over here. 5 and 1 make 6 oxygens. 2 times 3 makes 6, and that one's complete. There's another synthesis. You have aluminum oxide, so ALO plus water. Again, it kind of looks like a double replacement, but if you change the cations, you're going to end up with the same thing you started with, so that wouldn't make any sense. So we have to look down here. This is a metal oxide plus water, and it's going to make a metal hydroxide. So your metal hydroxide would be Al with OH. All right. That was the symbols and combos step. Aluminum's +2, oxygen's aluminum's +3. Oxygen's -2. So you have to have a 2 here and a 3 here. Water's water. +3, hydroxide, polyatomic ion, bottom of your page, has a -1 charge, so you're going to need 3 hydroxides to make that formula correct. Last step, balance. So this, on this side there are 3 atoms of hydrogen. I'm just starting with the hydrogens arbitrarily, so I'll put a 3 here, that gives me 6 hydrogens, put a 2 there, gives me 6 hydrogens. Let's see, when I put a 2 here, there were 3 oxygens on this side, so 2 times 3 makes 6. 3 oxygens here, plus 3 oxygens there, makes 6 oxygens. 2 aluminums, that one's done. Next example, iron 2 oxide, so it'd be Fe with O plus diarsenic As2 trioxide 3. Again, looks like a double replacement, but if they change partners, don't you end up with the same thing? So this one is a non-metal oxide, and a metal oxide makes a salt. This is the non-metal oxide, this is the metal oxide, and it makes a salt. So the salt is, for right now, we're just going to call a salt a positive ion and a negative ion. So the salt would be FeAsO. So you're going to put these in order of increasing electronegativities. So oxygen's more electronegative than arsenic, arsenic's more electronegative than iron. So in order of increasing electronegativities. So So now we've got all kinds of issues because we don't really know what the charges on the iron or the arsenic are. They're both variable, so we'll figure that out. So you go back over here. We know iron, actually, no, iron's a +2 on this side, so we're just going to assume that it's going to be FeO because it's +2 minus 2. We're good. Arsenic on this side, so we'll assume this iron's over here is +2. That just stays the same. If we look at arsenic on this side, O is -2. There are 3 of them, makes -6. So the arsenic has to be +6. There are 2 atoms of arsenic, so each one is +3. All right, so we'll say that's +3. Now I'm going to go down here. The arsenic polyatomic ion, whatever it is, has a -3 charge. Whether it's ASO3 or ASO4, it's still a -3 overall charge. And we now know that the arsenic was +3. So you're right here, +3. So 3 plus x equals -3. So what's x? X has to be -6. All right, so I need a -6. We know that each oxygen is -2, right? So if each oxygen is -2, then we're going to have 3 oxygens to make -6. Let's check that out. So 3 plus 3 times -2 makes -6. 3 times -2 is -6. Whoops, I meant to say -3. 3 plus 3 times -2 equals -3. So we have to have 3 atoms of oxygen. So we're going to put a 3 right there. All right. Now, we still have an overall problem because the arsenate's -3 as a polyatomic ion. Remember that -3? So -3. So this is 2, that's 3, so we had to put a 3 down here. Sorry about that. So put a 3 right there, and a parentheses around that, and a 2 outside the parentheses. Now we have our formula written. So that was the hardest one to figure out probably. But you look back over here and see what the oxidation state is and assume it remains the same. So to balance it, we need to put a 3 in front of the iron, and there's to match that 3. There are 2 arsenic atoms. There's 1 in the parentheses times 2. There's 2 here. There are 3 arsenic atoms, or excuse me, 3 oxygen atoms inside the parentheses over here. So 3 times 2 is 6. 3 oxygens plus 3 times 1 is 3. So 3 plus 3 makes 6. So we're finished. Next one's easier. These are just direct combination. Individual elements usually combine to make a binary compound. So sodium plus oxygen. Did you remember that oxygen is part of Brinkelhoff? And it makes sodium oxide. Sodium is +1, oxygen is -2, so you have to have a 2 there and a 2 there, and that's all there is to that. Okay, the last one is combustion. If you see a methane or an ethane or a propane on your problem set, you may have to look up what their formulas are, but methane is CH4 plus oxygen. Oxygen's O2. This one's the last example. They're pretty easy. They're hydrocarbons. They always make the same products, carbon dioxide and water. So right now my house is warm, and it's warm because I'm burning this gas in my furnace, and when I burn this gas in my furnace, I get CO2, and I also get water. Some of you will remember having seen steam or smoke coming out of people's chimneys around town. That smoke is actually just water vapor, which is a product of burning this gas. Also, you sometimes see water dripping out of a tailpipe. That's not this gas, but gasoline's a hydrocarbon, and it makes water, and that's why you see it dripping out of tailpipes. All right, so now we've got 4 H's on this side. There aren't any formulas to really think about over here because carbon dioxide and water always have the same formulas. Oxygen's O2, and then methane, you had to look that one up. I'll just Google methane or Google ethane. When we get back, we'll talk a little bit about organic nomenclature. All right, so we have 4 H's. We got 2 H's, and we're going to balance it by putting a 2 right there. So that gives me 4 H's on this side, 4 H's on that side. Then there are 2 O's plus these 2 O's make 4 O's. So on this side there's only 2 O's. So I need to put a 2 there, and that makes 4 O's, and then that one's balanced. So that is your combustion reaction. So remember to work on this over break, and I'll link all this stuff on the website.